And if I can learn to guess the size of the interval without thinking, then I can read music instantaneously. So the way we do that is
Windows.
yes. The other thing, just before I go on to this, I'll show you is, it turns out no matter how many sharps there are, no matter how many sharps there are, the last sharp on the right is always the number 7. So if I put a sharp here, the next sharp comes in here, next sharp comes in here, next sharp comes on this line here. If I take the one furthest to the right and say that that's the number 7, that's all I need. As a matter of fact, that's all I need. I don't even need to do the rest of it. Because once I've got that, I know this is 5, 3, 1, there's 1. Above that, this is a 2, that's a 4, 1 below is a 6. And now I've got that whole thing labeled, and I'm ready to read the music. You see this simple process? It's really quite simple. So, turns out, the other accidental that's used for telling us the key signature are these things called flats. And flats also come in a certain order. The first one usually comes in like this. The second one comes in like that. The third one comes in like that. And it turns out the last flat is always the number 4. So, since I know the last flat's always the number 4, can I now label all the spaces using this pattern?
Yes.
Going down, 2. Going down, 7. Going up,
6.
1, 3,
3.
and above that, 5. And one below 7.
5.
Now we've got 2 octaves. I have 2 octaves laid out there, which is big enough for any score, for any instrument, for any kind of music. And if this were a conductor's score and there were 25 staffs, and they were all in different places, all I'd have to do is figure out where 1 is on each one of those staffs, and I can actually, with my eye, track the whole score. So all you need to do now is learn to see those things, those interval distances, and realize again, if I want to write a song that goes like this, something like that, since this is where 1 is at, you can see that's where 1 is at, right? That bottom line there, then what I have to do is see the distance from here to that line is a third. If I put a note here, the distance from here to here is a second. If I put a note here, this is a unison, or 1. Put a note here, that distance there is 2. Put a note here, from here to here, distance is a 3. And now I can start seeing those distances, can't I? All right.
Well, how does that make you read the music faster?
You'll see. I'm about to do it to you.
Okay.
For all you adults out there, or whatever, I'm about to flash you. So if you don't want to get flashed, I think the camera's blinking for a change of tape. It turns out that you can learn to see these interval distances exactly the same way that a carpenter learns to see an inch. If you work with a ruler all day long measuring things, you get to a point after a while where you can just look at something and say, that post is 8 inches wide. And probably if I took a ruler over there and measured it, I'd probably be accurate within a 1/16 of an inch. It had a knot in it, and they used, from here to here was the sacred cubit. From here to here was the cubit. So they measured cubits. The rocks had to be multiples of that, right? So it turns out your eye can be trained to just see these intervals, okay? Now what I'm going to do is I'm only going to show you odd intervals right now, only odd ones. And I want you to guess, based on their size, Don't count 1, 2, 3, 4, 5. Just look at the size and say, it looks about that big. So the first thing I want you to look at is, you see that right on top of each other like that, where they're cuddled together? That's a third. That's a 3. If there is a space or a line in between, like this, then that is a 5th. See? A 5th. And if there is 2 spaces or 2 lines in the middle, can you see the difference in the sizes? 3, 5, 7. Now that's all I want you to know. Based on seeing how big it is, I want you to just say the number. And what will happen is, as we do this, you'll see that eventually all the chatter and talk in your left brain will just stop. Because as long as your left brain's trying to figure it out, you'll always get the wrong answer. But the minute you look at it and say, oh, that looks like 3 inches, that looks like 5 inches, that looks like 7 inches, you'll get it right almost every time. And I should be able to turn these cards at lightning speed, so we're going to work at it. You ready? Next one coming up is 3. A little bit bigger.
5.
A little bit bigger.
7.
Still big.
7.
3.
5.
5.
3.
5. 3. 5. 7.
3. 7.
5, 5, 3,
3. 5.
5,
5.
7,
5.
7,
5.
7.
7. 3.
3.
3, 3,
5.
5, 7, 3,
5.
5, 7, 7, 7, 5, 3, 5, 3, 5, 7, 3, 3, 7, 5, 3, 3, 5, 5, 5, 7, 5, 7, 3, 3.
Now, just in case you memorized it. Well, some people can memorize up to 10 numbers, it turns out. And when I was looking at this last week on the internet, I posted this drill on the internet, by the way, if you need to do that, go home and you'll be seeing this. I'll be putting this up on Sunday. So if you just go to the website, just go to the 10-minute segment that has this flashcards, you can just sit and watch these flashcards go by. And what you'll be doing is teaching yourself how to read music with your right brain.
What's your website?
It's at YouTube, and we're under Music Theory Workshop.
Okay.
If you type in Music Theory Workshop, up will come the last 11 weeks that we've done this, okay? Now we're going to do some more. You ready? 3,
7,
7,
7, 3, 5, 3, 7,
see you later.
7, 5, 3, 5, 3, 5, 3, 5, 3, 3,
You know I stand?
5,
You got it? You guys are new and
Five.
you're not saying anything, but I see a smile every now and then. So, and then when you don't smile, I know you didn't get it. So, I'm getting silent messages here. Okay.
7, 7,
Oops.
3, 5, 7, 3, 5, 7, 3, 5, 7, 3, 5, 3, 7, 7, 3, 3, 7, 7, 5.
Well, I proved my point.